In today's lecture, I'm going to talk about how to build this part inside a software product called Inventor. The first thing you need to know is units of measurement. Anytime you look at a part, appreciate the units of measurement matter. So here we have the part. It's 10 millimeters is the rule that we're using to figure out the dimensions of this part. So in order to figure out the actual numeric value, we have to count the squares. Okay, remember that. We got to count the squares. The perimeter of the part, I'm using my mouse, so my lines are rather crude. I'm not using a pen to do this, but my mouse. So my little blue lines that I'm trying to draw define the perimeter of this part. Okay? I'm trying to get every single piece in here as best as possible. For some of you that have attempted to build this at home already and you did it off your hand sketch, you probably have that bend in the front. It is very difficult to see this, but it actually closes like this. This is actually what the part looks like. It's basically a wedge with pieces removed out of it. See where I put the red X's? You see that? Okay? It's literally a wedge with pieces removed out of it. That's the reason you want to hand sketch this on the side before you start building it. This lecture presumes you've done that. It presumes you've checked the numbers, that you know the size of the part, and it presumes that you have a hand sketch near you as your visual reference. Those things are presumed. The students in the classroom, for those of you listening to this online, the students in the classroom have already been asked to generate orthographic projections of this part by hand, just hand sketching it. They have a printout of this and they've hopefully taken a ruler and measured it out. Not measured it in the measurement aspect of numeric values, but lined everything up. So these blue lines would be the product of you taking a ruler to the drawing you were given to identify its basic geometric shape. Okay? If you ever have issues trying to understand what you're looking at, the biggest thing I recommend you get is a box of colored pencils. Got it? That will help you tremendously to see what you're looking at. This face right here. And these are skill sets that were taught to you in 110 as far as how to extrapolate the shapes. So you need to transfer that skill set from that class to this class. The same skill set is covered in AutoCAD, the other class that we teach. So those of you who are in the 110 class right now, that if you're having a hard time seeing stuff, you're in 110, right? You want to turn around and get a box of colored pencils. They will help you with this because that's what I had to do when I was you, trying to learn this. It is visually challenging to see this, what I just drew quickly in front of you. It is hard to see. So you'll notice what I'm doing is highlighting with my mouse. Sorry for taking so long. It is hard to do this. I'm not using a pen. With my mouse, I'm highlighting the surface. Okay? I only have one color highlighter. Sorry, I will color all the surfaces for you, but I don't have a choice. When it comes to the other colors, I can choose different colors in here. I'll pick lime and a large pointer. Okay, this over here, I'm trying, sorry guys, is the side of this part. Okay? See that? That's where we left off last class when we were discussing this part, was looking at that side. Okay? This face is a wedge, is the biggest thing, and the only way you're going to see it is if you take a ruler and connect those little quarter marks, these guys. See those? As I'm erasing everything away. See those little marks that I mentioned to you around the grid? That will help you box your part up correctly. So I recommend you do that first, because without it, without doing stuff like that, at least for people like me, I can't see this part if I don't do that. So I'm trying to give you a method to the madness of how, if you cannot see the part that you're looking at clearly, box it up and start figuring out elements of it. All right? In this case, we have a grid helping us out, but it's not always the case. Many times you're going to have to do this yourself manually, and you're following the pattern of the lines. Like this line goes at an angle, that's why it's going at an angle. And that's how you're doing the connected dots business. So please do that on the drawing in front of you, for those of you that have this printout. For those of you listening online, take a snapshot of this, print it out on Word or something, and do the same thing. That will help you figure this out. So I'm dropping the blue lines in there as best as I can so we could go back to where we were at the beginning of the conversation. And now moving over to Inventor. Okay? We needed to know the units of measurement. We know we're going to do it the first angle projection because it's metric, but the first angle projection doesn't kick in until we're in detailed drawings. Remember that. So we're going to go to New. The first thing you're going to say is, why do you go to New? Why don't you just jump into New Part, right? That should be a question in your mind. Why am I telling you to do that? Autodesk is a product developed in the United States. Because it's developed in the United States, the default units of measurement for startup are in inches. SolidWorks, for those of you that know SolidWorks, that's a product that came out of Europe. So the default startup is metric. Get it? If you don't modify anything in your install. Got it? To be clarifying, how does that work? So my advice routinely is, don't use this until you know what you're dealing with. Got it? My advice for any new user, or if you jump on a computer you haven't been on before, like at an interview for getting a job, you're doing this stuff, go to New, okay, and pick New. You want this dialog box to appear. You actually want this dialog box to appear. And you want to have control over the units of measurement you select. You want to make sure you pick the correct units of measurement. And out of here, you want to pick the right one. So the question is, what's the right one? Let me go through it. Remember, there are 3 parts to a CAD file when you're in parametric land, as I like to call it. 3 parts. 1 is the modeling, making the part. 2 is, let's say if you had an assembly, it would be assembly. But 2 can literally be just creating a drawing. All right? But there are 3 parts. Making a part, putting that part in its assembly, and regardless of whether it's the part file or the assembly, you got to detail drawing it. Get it? So there are 3 elements you're always thinking of doing. If you only make parts at your company, I don't make the whole product, I just make a component, like a spring manufacturer just makes a spring that gets installed in somebody else's product, then the only thing you're going to do is make parts and detail drawings. Got it? As far as what kind of parts, when you get the choices, you have sheet metal of DIN, sheet metal millimeters. DIN is German. It's just a German dimensioning standard style. That's all it is. It is not literally a third style of detailing. All right, or I'm sorry, not detailing. What do you call it? Modeling. It's just German. DIN. MM is just good old millimeters. Not M&Ms, but I love M&Ms, but in this case, it's just millimeters. Standard versus sheet metal. The only difference is if you open up sheet metal, you get the sheet metal toolbar. That's it. Nothing else. If you're in sheet metal all the time, because Inventor is a very good sheet metal product, That's why they have that template already sitting there for you. Standard is just starting of drawings, just a normal drawing without the sheet metal toolbar on. Hypothetically speaking, if in the middle of you working on your standard part, you decide to make it a sheet metal part, no big deal. You can literally turn on the toolbar and move along. You don't have to start with a new template. Got it? So in our case, we're going to pick standard. Just so you know, under assembly, there's a whole bunch of assembly options. Mold design is a default, one of the default options. Weldments, for those of you in welding, and then standard. On the detail drawing side, you're going to see two types, the IDW and the DWG. Models are IPTs, Inventor Part is what that stands for. Got it? Inventor Assemblies, IAM. That's that suffix. Get it? The file name suffix. On the detail drawings, they let you go both ways. Are you going to create a detail drawing so it's a DWG file so somebody who's using AutoCAD can also open it? Or are you just going to go ahead and do it as an IDW, which is an Inventor drawing file, and detail it there and then send it to somebody as an AutoCAD file after the fact? Doesn't matter. Depends on your company. Who cares? Not who cares, but your choices there. Now here you're going to see more than DIN. You notice that? You see ANSI, which is American Dimensioning Style Standard, which is how you set your dimensions. You have BSI, which is the British. DIN, which is the German. Oh, I think I screwed up. I'll have to, yeah, no, I'm okay. DIN is German. GB is Great Britain. It's GOST that made me stop for a minute. The GOST, I think GOST is Russian, but I'm going to let you guys look that one up. Got it? ISO is the International Standards one, the default that we're going to be using, ISO. And JIS is the Japanese. That's just different ways of putting annotations on your drawings, different dimension styles. Where does my dimension exist versus the dimension line, extension line, blah, blah, blah. That kind of stuff. It's more about presentation and less about the model. Make sense, guys? That's why there's so many options. As many opinions are out there, we've got standards in some ways. And then the last thing you might do, and this is much, much later, is presentations. This is where you do animations, guys, is in presentation. It's like the fourth thing on the list. You can actually animate your product, which is kind of cool. Cool. Back to this. For today, we're just going to basically make a standard part. So we're going to pick, it's in metric, and we're going to say create. That's the best way to start when you walk up to a new computer. Remember, the computers in this particular lab have lobotomies every time you turn them off. So even if you do create a new standard, guess what? It's gone. So if you have your own toys, as I like to say, you could do whatever you want, but be aware of this reality and cognizant of the potential changes you're going to have to account for when you go to somebody else's computer. So remember how to change your settings. Now, looking at Inventor as just the way it's set up, the first thing I want you to know is on the left side is called a model, as in model tree. They call it a tree because after a while you got a bunch of branches. Make sense? That's on the left side. On top are a bunch of tabs. Yes, it's a tab-happy product, just like every other product out there. You can literally go into each tab and look at every single item. Just put your mouse over an item and stop and watch. And it'll explain each icon to you. Okay? If you're one of those mouse-happy people that has to keep moving your mouse around like this, stop it, please. Okay? Just, those of you that have had me in the past, it's the first thing I tell you to do. You want to go over a command, you immediately want to jump into it. You don't want to give it the few moments of pause. If you need to, let go of the mouse and just pause it there over any icon, and it'll literally just tell you what it is. And you'll notice at the bottom of each item, it'll say, press F1 for more help. So that's all you got to do is hit your F1 key, and boom, it'll go through a whole explanation of whatever it is. In some cases, they even have videos. Cool. There's a lot of support opportunities for you, so don't sit there going, until I cover it in class, I'm not going to touch that icon. By all means, go right ahead. Test it out, see what it does. Got it? It is actually good for you to do that. If you get ahead, go ahead. I'm the last person that's going to tell you you have to wait till I lecture on that. I can't even keep a straight face saying that. You'll never hear that out of me. By all means, move ahead. So each tab has what they call, I'll call it, that this is their term, what do they call it? A toolbox, I think is a term if you jump online. Each little section, like this is create, modify, get it, explore. Each little tab inside has little toolboxes of stuff. The toolboxes that you can't use are grayed out. You see that? There's nothing there. There's nothing to modify. There's nothing to pattern. There's nothing to constrain because we're not in that command set. Cool? So you can look through each one of these and see what they talk about. On the left side, back to the model tree, part name is right there. If you put your mouse over it, right mouse button, go to I properties. These are the properties of the part. This is useful to know two places. One, at the end of our model, when we're done building this thing, you want to pick up its mass properties, because that's one of the questions on the homework assignment. What's its volume? Two, and when you're detailing the part later on, you're going to want to change the author from design 1 to your name, whatever, in this manner. Okay, first initial, last name, in caps. That's how we do it at companies, or at companies we'll just say our initials, like AS, whatever it is. Got it? So in our case, I would ask for you to put your first initial, period, space, and your last name in all caps. Got it? That's what you want to do with your items. Design 1, it pulls off the, I think that's the computer name, is design 1. So personalize it, please. Cool? And if you personalize it here in the model, guess what? It gets carried over into your detail drawing, so your title block naturally populates correctly. So if you give me a drawing later on, a detail drawing that says design 1 is the author, I'll know you didn't fix it. Get it? So you may as well know up front. The other things you can do is, if you want to create a company name, you're welcome to do it. I don't care. I just threw something in there. Cool? Got it? Hit apply, whenever you make any of these changes. Project, you can actually put a whole bunch of project. Designer. So not only are you the author, you can also be, you should be, designer. Get it? You might also be the engineer and the authority. Get it? And typically you put different people's names on here if you have a real job at a company, because different people check drawings. Part number, stock name, description, you can fill all this information in. You can call it Farfignugan, whatever name you would like to call it. No swearing, please. Revision, when I give you a drawing back to correct whatever you have to correct, I need you to update the revision. This is where you would do that. Cool? Things like that. Estimated cost, we're going to give this thing a price of, there we go. That's good enough. It's a very expensive part. What's neat is when you assign the prices to each of your parts, you can actually extract a cost sheet off your product. So if any of you are in a different class where you're using this product for your modeling, okay, like maybe you're in a machine design class or fluid power class, whatever it is, if you assign a cost to it at the end of the day, you can actually pull out that cost sheet and put it in your PowerPoint. Ba-dum-bum. Hint, 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 for those of you in that. Cool? I would not recommend $1 million price tag, mind you. You want something realistic. I just threw that in just to be funny. Can hit apply and close. Cool. That's just some of that info. We'll talk about more of that later. Next, in any parametric CAD product, you are literally out in space. Okay? In the classroom, I can visually show you with my hands, right? I can't grab something. I'm trying to show you on the computer screen by moving my mouse around. I can't, and clicking. Hear that tapping noise? I can't click on anything. There's nothing there. The way that you navigate this product or any parametric CAD product is you need a place to land, to draw on, to create your first base sketch. How do you navigate? When you look at the screen, on the left side I told you have your model tree. On the right side you have your navigation tools. All right? Up here, you're going to routinely hear me say to you, if you're having a problem, you zoom too far out, you zoom too far in, you can't see where you are, you can't see something. You're going to hear me say, go home. Why? Because it looks like a little house and it says home if I leave my mouse there long enough. When you click that, it takes you home. Home is your traditional cube, front, right, and top. Remember that. Remember the cube. Respect the cube. Got it? In modeling, you must respect the cube. It makes the rest of drawing easy. If you ignore this thing and just decide to go off in la-la land, you're going to have issues later on detailing. I'm not going to be able to fix them. You're going to have to fix them. Cool? I don't want you to have that problem, so I'm telling you up front, respect the cube. Don't just draw any which way you want. With this in mind, respecting the cube, where's the front of the part? That's one of the first things I asked you guys to do last class. That's the front of the part. Whether you like it or not, I don't care. That's not the point. It's not about preference. It's about the orientation that you were given the part in. I've worked on parts that I haven't liked. And I do want you to become comfortable with doing this, because your boss might tell you, this is the view I want you to draw it in, whether you like it or not. Just, suck it up. Let's do it. Cool? It's not that, difficult a thing to do. I put F for front, R for right, so obviously this is the top. Regardless of whether it's first angle or third angle projection, the cube doesn't change. This is it. Just work with it. Cool? Next, when you look at finding your place to land on, the first thing you need are your planes. That's how every parametric product works. It's not unique to Inventor. So when you look at your origin, you're looking to assess your different planes. See that? These are your planes. You want to turn them on, or you can leave them off. When you do this professionally, you might never turn these on, because when you touch it, it activates. See that? When you put your mouse over a plane, it activates. See that? However, because this is an intro class, I'm going to try to at least tell you to turn them on. So if you pick the first one, pick the last one, I was holding my control key. You notice how nothing in between highlighted. Okay? But the two items highlighted. You notice that? If you click the first one, hold your shift key. Pick the last one. Oh, come on, you. There we go. They all turn on. Do you see that? So if you want to select everything to turn on in one shot, hold your shift key down. If you forget, like I do all the time, just experiment. It's okay. Cool? Before you move your mouse away, you can let go of the shift key for the next step, but don't move your mouse away, because if you do, you're not going to get the option right that I'm asking you to have. Instead, if you hit your left mouse button, everything turned off. Darn it, gosh darn gee willikers. When you hit the right mouse button, you got a bunch of options, but nothing to turn the planes on. Get it? So I want you to go back, pick the first item, hold your shift key, pick the last item, right mouse button, while your mouse is over the items, and then you get a select set of options, including visibility. Just as a creature of habit, do that. There you go. Now all your planes are on, whether you click away or not. Now, how do you select the plane you want? You actually have to pick the edge of the plane, 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 the edge of the plane. Do not go to the middle of the object. Do not go to the middle of the object. Get it? I'm saying this to you because too many people immediately go for dead center and they're like, why can't I pick anything? Because there are too many objects cohabitating the spot your mouse is sitting over. Get it? The only way the product knows exactly which plane you want is you have to actually approach just that plane. Cool? Now, you tell me which way you want to build this. Do you want to build it? Because you can build it more than one way. Do you have an opinion? Anyone got an opinion? Give it to me. Nope. Yes, go for it.
I personally talk about YZ plane.
The YZ plane, and the reason you're using that language is because that's how they call it. So the YZ plane, which we would consider the right side of the object, I agree with you. That's not a bad idea. Let's do it. Cool? So we're going to start with the right side of the part. Now, if you're asking where you're getting that from, it's the right side of the part, people. I'm not joking. That's what it's called. When you click once on that plane, you do get an option to create a sketch. You get this option the first time. Other times you might see different options, okay? So just be aware of that. You can create a sketch 3 different ways. May as well just tell you now. Method 1. I'm going to extrude my part, so I intentionally pick extrude. I'm going to revolve my part, so I intentionally pick revolve. Get it? Your ultimate goal is to make a 3D model, not sketch. So a lot of students will start with the first tab and say 3D model, now I want to make a model. This is an extruded part. Let me minimize this again. This is an extruded part because it's basically a big box, a rectangular box. Got it? If it was round, like this dude, then I start with a revolve. Get it? This is an extrude. This is a bunch of extrudes. There's a couple ways to make this guy, but extrude. This is not a revolve. This is an extrude. This is an extrude. Extrude. Revolve. Extrude. I could make this with extrudes if I wanted. I mean, there's a couple ways to do this. Again, this one can be made both ways, extrude or revolve, to be honest. I can go both ways on this guy. But this is an extrude. There is nothing round on this thing. The only time you think of revolve is if it's round, which this isn't. So I'm going to hit extrude. When you hit extrude, the first thing you see is a little pencil with a little piece of paper. It doesn't tell you what that means. I'm sorry. I wish it would, but it doesn't, but that's okay. What that's asking you is go pick a plane that you want to create a sketch on. Do you hear me? That's what that literally means. I can't snapshot this image and like write all over it to tell you that, so you can only hear this from me. So when you see that little pencil and the little piece of paper on it, that means pick a plane you want to sketch on. That's one way to create a sketch. The second way is in sketch. Start a sketch, literally go and pick a sketch like a rectangle, then it's going to ask you the same thing. Where do you want to draw it? The third way is you pick the plane and start a sketch. Get it? Those are the 3 ways to start your drawings. Cool? Okay, I'm going to stop giving you 3 methods at this point because it can be very confusing and you're like, please move on, right? How many of you want to say that to me? So we're going to go ahead and build it. You have multiple ways to draw this object. I'm lazy, so I'm going to pick the path of least resistance. I'm actually going to attempt to draw, as you can see, I'm scribbling what I'm going to draw on this side. I'm going to draw the whole side. This is why you want to hand sketch for yourself a little bit. It's going to help you define what you do. This software, like every other software, does absolutely nothing until you tell it to. Did you hear that? Did you hear that? It will do absolutely nothing until you do something. You literally have to build what you're trying to make. It's not going to do anything for you. That's why you have the hand sketch. So I'm going to go into create. I'm going to create just lines. Is this the only way? The answer is no. Just go with me on this one for now. So I'm going to basically sketch out a basic shape. So I sketched out a shape, but I did it too well, so I got to get rid of it. Darn it. I'm going to sketch it out again. This time, not so good. I'm going to start correctly. You see that little dot that's right there? That's called a constraint. You can constrain your objects inside sketches two ways. It's constraints of geometry and constraints of dimensions. Two types. The geometric constraints that we apply in here are directly from metrology. So if any of you have had a metrology class, the symbols are identical. They're actually on our wall, right in the middle of this room. For those of you not in this classroom or you're at home, take a picture when you're in this classroom of that poster. If you're not here at all, jump online and look up metrology symbols and you'll see what I mean. You can, of course, do what? If you're confused on constraints. Put your mouse over it and leave and let go of your mouse and it will explain to you what it is. Cool? So this one is a point constraint. It visually shows you that. You see how it shows you a little picture of, hey, I'm going to point. You see the blue arrow pointing to the red dot? And it's telling you the coordinates it's locking you down at. If you don't see a green line when you draw or a green reference of any kind, see when I go across, see another constraint. Look on the right side of this image. You see another little constraint. You're like, what does that one mean? Go up here and it tells you vertical constraint. Don't worry about it being a horizontal line. I know it sounds confusing. Ignore that. On the constraint, just ignore that and just keep working. Now you have another one. Looks like a T that fell over on its face. That's this guy. Perpendicular constraint. Okay? Then I'm going to go across and I have another one. See that? It's another perpendicular constraint. That means 90 degrees from the other line. If you foobar and don't draw it correctly, that's fine. Don't worry, we can fix that. Your last line, you want to just go back to the origin and just click. So here we have the lines of that basic shape that you want to build, but this line is not horizontal. You got bumped, you moved your mouse incorrectly, whatever was the reason. Click on it, and now you can actually apply a constraint. Now watch what I'm going to do. I'm going to pick horizontal just for fun. And it went straight up. Gosh darn it, you willikers. Hey, like I said, pay attention to the constraints. Don't stress out. If that happens, undo. You saw me go to the undo. Click on it again. You have choices. You can pick vertical, which ironically is the correct one. How do I know that? Because that's what it did to this line down here. It's the only reason I know that. The other reason I know it is because it gave me the wrong shape the first time. It jumped it straight up. It's counterintuitive to what you're trying to do, but this is a 3D parametric modeling product. It doesn't see things the way you think, the way you see it. Got it? I'm just giving you the facts. I'm not trying to mess with you. You got to work with the product the way it is. The other thing you can always do is pick this line like it is. Hold down your control key, pick the other line right here, and pick perpendicular. That makes it 90 degrees from each other. Got it? In order to use this command, you got to pick both lines. You can't pick perpendicular to one line because it's perpendicular to what? It can only be perpendicular to another object. Cool? Next. I've got my basic shape constrained geometrically. Now I need to apply the last set of constraints. which are constraints of dimensions, dimensional constraints. So we're going to do that. Now I'm going to pick from this end to this line. Do you see how I intentionally don't pick the lines? I do that intentionally because you actually get better control in your dimensioning standards. That's a word of advice. You do what you want, I don't care. But here's the way I recommend you do it. When you dimension an object, you want to not pick just the line of that object, you want to pick its side walls. This one doesn't have a side wall, it has a point and a side wall. Now the question is, what's a dimension? So now you got to go over here and actually count it out. Did anyone do that work just so we can make this life shorter? Otherwise I'm going to start counting. A 1, 2, 3, 4, 5, 6, 7, 8, 9. The count. There. Sorry. Went back to my old Sesame Street days. Cool? What did I say? 9. Each box, each grid block is 10 millimeters. So that's, I just counted out 9. So is it 9 millimeters or 9 centimeters? 9 centimeters, which is the same as saying 90 millimeters. So remember your units of measurement. Ironically, in this box here, you can actually just say 9, and if you remember, centimeters. That's the interesting part. You can actually define the unit of measurement, not simply the numeric value of that unit. Cool? When you hit enter, that's exactly what you're going to get. 90 millimeters. When you click on this, it's going to show 9 centimeters. That's visually challenging, but I wanted to show it to you that you can do that. All right? You can also put in math equations, which I'll show you shortly as well. Now, vertical, 1, 2, 3, 4, 5, 6. So from top to bottom. You notice I do not pick the side line. Pay attention very carefully on this one. There is method to my madness because I use this product in industry. I'm not an academic. All right? This is an academic. To tell you to just pick this line and dimension it is academic. On the industry end, I'm going to recommend that you pick the top and the bottom object. The top and the bottom of the object to dimension it. Okay, what was the number I gave you because I forgot already?
6.
Say again?
6.
6? So that's 6 centimeters though, right? Right? Get it? 60 millimeters. Now, the last dimension we want is here, so that's 1, 2, 3. So I'm going to pick, now the question is how do I do this correctly? I'm going to pick the side line, and I'm going to pick this point. If you pick this line, it wants to do angle. You notice that? See a little angle picture? I got to pick this line. Pick the point of the end of that line. And then I can type in 30 because it's 30 millimeters. Got it? And that is how you get the correct shape, basic wedge shape. The basic shape. Got it? Don't compartmentalize the work too much. I always like to say, start with a large block. Start with a block and then whittle away at it a whittle at a time. I literally say it that way. Start with a block and whittle away at it. Did you hear that? That is my general suggestion, regardless of which CAD product you use, outside of AutoCAD, of course. Then I would tell you to use offset everywhere and save yourself a ton of time. That's another conversation for a different day, different class. In this class, I suggest you start with a block of material, the basic shape, the most basic geometry, of course, is that big rectangle. I'm not starting that basic. I am starting at least with the wedge shape. And now you get to whittle away at it a whittle at a time. So I'm going to go and I'm done with this piece of it. I'm going to go to 3D model. I literally just jumped over to the tab called 3D model and I'm going to hit extrude. It automatically picks the shape because it's the only shape to pick. And now it's a function of how far do you want it to extrude. 1, 2, 3, 4, what is that, 6? 1, 2, 3, 4, 5, 6. So I'm going to extrude at 60. Now here's what's interesting to know. Unlike SolidWorks that compartmentalizes extrude cut from extrude, Inventor does not. Everything is all encompassing. Obviously, it's the first object, so there isn't much else you're going to do to it. By the way, when you want to pan, pick the little pan option so you can pan over, or it's how you zoom. Got it? You zoom where your crosshairs are. That's how you navigate this product. You zoom where the crosshairs are. Make sense? Just roll the middle wheel back and forth. You cannot hold your middle wheel to pan. You have to go and pick the little hand, and then you can pan. All right, guys? What do you do if you get lost? Go home. Get it? If you ever get lost, just go home. Don't get up and leave. Just go home. Cool? So if I accidentally do this, oh gosh darn gee willikers, where did my part go? How do you fix it? Go home. Just like that. Got it, guys? Just remember that. Go home. This behavior, the dialog box asks for the profile, which it automatically selected. From, which is the plane itself. Direction. I can go one way, the other way, through the middle. And then I can even change. One side could be thicker than the other side. How about that? I'm going to go symmetric just for fun. No real reason. I'm just doing it. Got it? Literally, just to do it. Alright? And I hit OK. There's your basic geometry, your basic shape. Now you want to whittle away at this a whittle at a time. Now comes the fun part. I'm going to orbit. So I pick orbit. I'm going to change the orientation of this, and I'm going to look at the back side of the part. You're going to ask me why the back side. To be honest, because I have a face to select. If I pick the front side, I would have to pick a plane. I honestly don't want to pick a plane. Here's the reason. Anytime you create cuts off the plane, if I move my cheese, I'm just saying it jokingly, if I move my part, do you think my cuts are going to move with my part? No. Okay? That's why everything after the first move that I make, which is making my part, everything after this, I really do want to use the model. I want to attach to a face of the model. I no longer want to select a plane. Do you hear that? I want to pick the model to create future sketches. That's just a good practice to have. If you have the other practice or the other habit, you're not gonna like me the way I'm gonna say it, but I'm gonna say it. It's your problem. Because it actually creates problems. So my word of advice, after you make your basic shape, everything else needs to be built or cut off of that shape. No longer do you use the planes. To make it very clear on that subject, I'm actually going to turn all my planes off. Every single one of them. So now you don't see them again. Cool? Ignore them. You want to use the model now. And if you get lost, go home. Use this cube. It actually orbits rather nicely for you. You don't need to use this command at all. See that? See how I'm twirling it around? When you pick the corners of the cube, it rotates it around for you. I don't mean just on top. I mean every which way you want to. And if you get totally lost, go home. Got it? I'm going to pick the back corner because I want you to see what I'm going to do next. I'm going to pick this face to make these cuts. And then after that, I'm going to pick this bottom face to make those cuts. Get it? I'm going to pick the back face, and I'm going to create. You have the opportunity to edit your sketch, share your sketch, make a sketch visible, and then the last thing, which is create a sketch. So I'm going to create a sketch right on that back. I'm going to identify these two shapes. The first one is at an angle. This guy right here. So I'm going to clear my screen again. Now I'm focused on the back and these two objects, and what do I notice? I'm going to change the color that I'm working with. I want to make a sketch that basically looks like this triangle. Yes, I know I can't draw with the mouse. Thank you for letting me know. See that? On the other side, what's interesting, this is where your sketching tools come in, your hand sketching, because you're trying to figure out what does that look like back there. You got to carry your lines to the back, carry your lines down and across, and what you realize is it's a box. It's just a rectangular, it's a little square box back there. Got it? Can you do both at the same time? The answer is yes. It doesn't matter at all. I'm going to make the box first. Why? Because I just want to. There's literally no reason. Whoops, I picked the wrong command. What did it just do? Interesting. When you try to create a box, you have several options. 2-point, 3-point, 2-point, center. That's the one I accidentally selected. The way that you know what your product, what your feature is going to do, whichever one you pick, whichever sketch tool you pick, is look where the blue dots are. The blue dots. Get it? See the blue dots? That's your visual indicator. If you don't understand it, again, put your mouse over it, take your hand away from the mouse, pause, and it'll tell you what it does. Got it? If that's not enough, hit F1, and it'll tell you more. Okay? This product will talk to you if you let it. Cool? So what was I going to do? I forgot already. I can't remember. Am I in the right place? Am I home? What did I just do? I went home so I could tell where I am. Did you notice that? Does it matter? See that? As long as I see the back of it. Now watch this. Can you only draw if you're looking dead on to the view? The answer is no. I'm intentionally going to do this in isometric. I'm going to pick rectangle. And I literally am picking that intersection and drawing that. See that? I do not have to be looking at that plane dead on to draw anything. But I have to know what I'm doing. It's very hard to tell if I'm in the correct orientation or not. See that? Now notice what I did. I just drew a rectangle or square, and then all I did was draw an angled line. What did the product do? The product gave me a yellow line up here and a yellow line over here. What on earth are those things? I'm going to tell you. Those are construction lines that are actually usable. When I open this dialog box, I'm sorry, the toolbar set, so you can see everything. This yellow object here and this yellow object there and that yellow dot down there are part of this family. Construction. You have the opportunity to change construction geometry like this that automatically appears in yellow solid to yellow hatched. If it's yellow solid, you get solid line, you can actually use it to literally make your cuts. If it's hatched, as in, sorry, let me leave the mouse there, sorry. As in a little dashed line, okay, turn it into dashed lines. You see it, a little sample that's on the screen. That will make it literally construction geometry that doesn't interfere with you. Depending on what you're building, you might want to change it. The actual help line that it threw out there in yellow to a construction line that just is there for reference. It depends on what you're doing. Got it? This is a feature of Inventor that's a benefit and a curse. That's why I'm telling it to you now up front. When you see all those little yellow lines appear, sometimes it will help you, sometimes it will hurt you. Okay? I cannot tell you which until we see the fiasco that it might create. Every product does this. SolidWorks does the same, and you have to do the same thing. You have to know which way to work it. In this case, I'm going to move my mouse away. I'm going to see if it's going to help or hurt me by going into 3D model and picking Extrude. When you pick Extrude, because there's multiple geometries, what's nice is it's helping me. I pick my square, and I pick my cube. Remember I told you, Inventor, it's all in one. That's what I like about it. It's an all-in-one package. One dialog box, multiple activities. I can either join it, which means I'm adding material. So you see I want to add material out there. Or I can cut, and it flips it into the part. You see that? Or I can get only those objects left. That's an interesting outcome. And one of the neat things is people ask me, what on earth would you use this? Have you ever tried to build a pyramid? That's where you would use this. And I can show you that later, but not right this minute. But if you want to build a pyramid, you use intersect. It's a very quick way to build a pyramid. Just a little heads up. In our case, we're going to pick the operation for cutting. Now the question is, how far should we cut? I'm lazy. If I change the shape of this object, I don't want my cut limited to 60 millimeters because my object might get really bigger or much bigger later, yes? So what I'm going to select is instead, there are two ways. One is through all. I find through all to be slightly annoying, especially when I start adding geometry later on to this thing, if I was going to. So what the one I like to select is 2. That controls where I'm going to extrude to. So I want to extrude to that face. Do you see that? When you do that, you control everything about it. Its future changes, get it? If I change the dimension of the object, if I change the angle of my cut, of my wedge, let's say the customer comes back and says, oh, I want a different angle, I want a specific angle. Get it? This cut will just keep going with it. No worries at all. That's the para side of parametric. It works with it. That's why I'm suggesting you pick face. I hit OK. Did I screw up at all? What did I forget to do? Dimension the thing, right? Remember that? Gosh darn gee willikers, I forgot to dimension this thing. So after the fact, you can go back and go to the sketch, and you can right mouse button and edit sketch and fix that. No problem. Now, of course, it picked the wrong side. Nothing new. So how do I get to where my sketch is so I can see it? 2 ways. One, I can go home, and I'm like, oh, okay, you're back there. So I flip to that side. Or 2, what's the other way? If I want it to stay where I was, I'm going to finish the sketch. I'm going to go click on this again, right mouse button, edit sketch. I can change the way I'm looking at my object. Right now it's a solid body. I can literally go under view because I want to view my object differently. Put that in your notes. View my object differently. So I go to the tab for view. Get it? That's the logic of the software, just so you know. And I want to change my visual style from what it is to wireframe. So now I can see, boom, right through the object. Get it? So I want to view my object differently, and I want to change the visual style. It was realistic, and I changed it to wireframe. Now I can, in this view, go ahead and apply the dimensions I need to apply, the dimensional constraints that are important. Now notice I picked the midpoint. No, I don't want midpoint. So I just hit escape, go back to dimension. I want to pick object to object. Go out here. And what size square is that? 20? And I hit that. Now, okay, I'm lazy. You know, if you haven't heard this enough times from me, it's recorded for life now. I don't want to put the other 20 dimension in. I'm going to, but if I didn't want to, what would I do? How would I fix that? The reason I'm going to is because you need it for your detail drawing. Every dimension you drop in your model appears and populates your detail drawing later. That is how every parametric product works. So don't get sloppy about dimensioning. You want to drop your dimensions for all your sketches here. That way they automatically pop up over in detail. Remember that, please. So you can pick dimension from here to here and then pick that. And then guess what? I'm too lazy. I don't want to type the number in. I'm going to actually pick the other number. Do you see that? F of x? How many of you have taken your algebra and your pre-calc and you're like, function of x? When the heck will I use f of x? This product uses it. F of x, D7. What the heck is D7? D7 is the computer tag to that dimension. Get it? Every time you drop a dimension, it assigns a number to that dimension. That is the handle for that dimension. Get it? No, you will not know which dimension has what tag in it. You'd have to go into the code to see that. But there's no reason to worry about that. All you do is pick the other dimension and it's done. Then you hit OK. So f of x is 20. Function of x is 20. This is your function. If I change this to 22, the other one changes to 22. Do you see that? If I change this to its correct number, 20, the other one goes to 20. Got it? Be lazy. This is what I mean by lazy. I want you to learn how to operate this product efficiently. To me, laziness is about efficiency. Next, this guy. Jeez, what is that? It's 1, 2, 3 squares in. Okay, so it's from here, from this dot to this side wall. What was that, 30? Is that what I said? 3 squares in is 30 millimeters. Gosh darn, that one's way down there. But what is it the other way? Here to this dot. Can't quite get to that dot. See that? See that dot? Can't quite get to it. So let me try it one more time. Notice what I have to do. I've got to pick the dot first, then the side wall. See that? Little things. You'll only get better. So I pick the dot. I go back to dimension. I've got to pick the dot. Why isn't it picking the dot? See, it won't pick the dot. If I pick the line, there it goes. Now it picked it. Sometimes it gets a little finicky. So, but if it wasn't going to behave, what I would recommend is go to that side, because sometimes the location matters for it to pick it correctly. Little things, little troubleshootings there. Now it picks it perfectly. I don't know why it does little weird things like that, but it does. So this one is 20. When you're good to go and you're like, wait a minute, they're both at 20. Sharis, why did you put two numbers in there? Because I didn't notice. Okay? Now, is it horrible that I made one side dimensionally? I didn't do the function of x? Yes and no, 6 of one, half a dozen of another. Did you hear that? It's okay. You know, that I dimensioned it independently. There are other ways to constrain them together, but it's not a bad thing that I dimensioned it by itself. If the client decides to change the angle cut to something else, I have complete freedom. Cool? That's the reason I did not choose to lock them into each other. Now those sides are done. Now what do I want to do? I forgot how to change this. See, it's viewed like a big open box, and I want to view it like a solid. I go to view, remember this, and I go to realistic. Realistic, shaded, maybe I want lines, shaded with edges. There you go. Good. See how you can go and play with it a little bit? How do you want to view it? I don't care. Your call. Shaded with hidden edges. Look at that. That looks cool. Isn't that cool? Hey, shaded with it. I'm just showing it to you, just to show you. Got it, guys? Okay, I want to get to the underside of this part. What's the fastest way? Use the cube. Hands down. Boom. Fastest method. Got it? I want to get there really fast. Hit bottom. Cool? If I don't like it, go home. Get it? The cube is a very powerful tool. Allows you to do a lot of neat things really fast. So now I can pick the bottom, create my next sketch, and I would look at this object. If I want to rotate this a little bit so I could see it kind of how it really looks underneath, I just did it. I've got two squares. Looks like two square cuts. I see them. See that? There's this cut. and this cut. Now, some purists, you will hear them, insist. So I'm going to just stop for a second and just kind of spell it out. There are people out there that will insist that every single thing that you do has to be separate from something else. Got it? You'll notice that I combined extrusions here. Do you see that? Somebody else is pulling their hair out watching this video when this video gets uploaded because I put it on YouTube. Someone's going to be pulling their hair out and complaining that I did this as one extrusion. They're going to insist that I need to have every single element independent of the other. And my answer to them is yes, you're correct. That is actually a very good habit to have. I agree. When you make your sketches, it is actually a good idea that every feature be independent of the other feature. Why? Because in the world of machining, for those of you that are sitting next to our CNCs, guess what? Every single cut requires a different tool, right? So I would agree with that individual complaining about the fact that I put two sketches in one cut. You're right. In the grand scheme of things, if I was going to be the machinist, which is a good way to think of this, I would want each one of these isolated because then I could isolate them with tool paths on the machining side for CNC. So be aware of that reality. However, clients are a pain in the butt. They're just going to say, this is what I want. And they're going to say, this is how it is. And then somebody else wants to machine it. And when you send the file to the machine, you are still going to have to break out everything anyways. In a perfect world, each extrusion or each thing that you do is seen by the computer. But in that same perfect world, guess what? Products like Extrude will still be able to separate the geometry out. Got it? So every product is changing and is getting better every year. I don't know which CAM product somebody might be using, but it will break the products out. Don't stress out over this too badly. But if I wanted to be a purist, which I can be, and I delete this, and I'm like, I'm not going to delete my sketches. Do you see that? I hit OK. Guess what I have? I have my sketches. I can be a purist and just go ahead and extrude only one item. Up to surface and hit OK. If I choose this approach, now I have this extrusion. I can actually share that sketch. I can actually share that sketch. And when I share that sketch, I can then select just that piece, which is slightly annoying how it's seeing it, and switch the direction that I'm cutting this way and hit OK and still get the same results. See that? So now I have two extrusions off of one shared sketch. Cool? Did you see that? It's recorded, so you'll have it for posterity. It does visually show that sketch, so you can always turn off visibility so it doesn't annoy you. When you click on a sketch, right mouse button, you can turn visibility on or off right there. Cool? Last step. I'm going to create the other sketches. I'm going to create a new sketch here. I'm literally just going to draw a rectangle here. I'm going to draw a rectangle here. I'm intentionally making them random. I see them. See that? I see them. Okay. I can, this way, for this time around, what I'll do is only make one of them. How's that? So I won't irritate anybody who wants to scream about why I made two sketches in one sketch. By the way, that's the reason I did it, so I could show you how to share a sketch. Okay? It's a very complete video with content, so just listen through the whole thing. I'm going to pick the two lines here. What's the width? 20? What's its length? Depending on how you look at it. F of x, I just picked the other object, so it's 20 by 20. Done. I'm going to go ahead and extrude it. I'm going to extrude. See, the dialog box jumped out here. I'm going to extrude cut. To where? Where do you recommend? I said to surface. Always keep that thought process in your mind and hit OK. There's my cut there. The other one I'm going to do the same thing with. I'm going to pick this face, create a new sketch. This is how you would do it on the puristic approach. Got it? Where I independently do every sketch by itself. That's what I'm doing this time. Again, I'm going to assign the dimensions to it. Whoops. Now here's something, another little tidbit. You see how I'm typing in 20? That function of x that I showed you guys? I gotta X out of this to show you this. If I turn this sketch on for visibility, I go back and edit this sketch. See that? Remember that function of x business? I can function of x to another sketch for dimensions. Just to show you that I can do it. I just want to show you that. Got it? It's an interesting thing that you can do. It's a little odd, but it's doable. So then when I change this one dimension, all of these this cut and this cut will change together. Anyone ever want to do a tire rim, like for a car, aluminum rims? Anyone like to design an aluminum rim? If you did, this function works beautifully to allow you to actually create the design and get uniformity of every single cut. And all you do is change one number and you can update it for different diameter rims. How about that? I had one student do that. It's wonderful what he did. So you're welcome to do that. Now notice the part shoved itself out. You see that? So I'm going to put it back in. So it locked back in. So I'm going to pick, again, a dimensional constraint for the width here to here. What's that width going to be? 30. Cool. Finish that sketch. I'm going to turn this one off because I don't want to see it anymore. Turn the visibility off. And then this last one, I'm just going to go ahead and extrude it because it's the only unconsumed sketch. It automatically picked it. If you had multiple unconsumed sketches, you'd have to select it off the list of sketches. Again, I'm going to cut and I'm going to choose two so I can cut to face and hit OK. Done. The way to test, like this is what this asks. The way to test if you did this right, you actually can check the dimensions. In your homework assignment, it asks you to check the dimension from here to here, 1 to 2, and 3 to 4. That's done in this manner. To write that information down, you actually go to what's called inspect and measure. You're asking to measure from position 1 to position 2. When you do that, it gives you the numeric value. So if you don't get 66.332, something's wrong. Got it? If you measure from position 4 to position 3, or vice versa, depending how you look at it, and you do not get 108.628, your dimension's wrong. The next check for yourself is found in, what was that called? In the right mouse button at the part level, iProperties, remember that? That last tab called physical. when you look at mass properties, okay, update it. When you hit update up here, it'll tell you the mass properties. The volume is right there. It's a monster number. So that's 176,000 millimeters cubed. That's its volume. Cool. If you don't get those 3 answers that are in this video, check the work. The other way to check the work is to create a detail drawing. Okay? Then you'll find out if you have any mistakes. Because when you dimension this thing, if it doesn't come out to the dimensions of your drawing, then you know it's wrong. Of the model. Got it? You won't be doing this kind of stuff at work, other than the fact that you might be checking for dimensional spans related to your product design. That's a whole different conversation. Volume, by the way, changes in respect, I'm sorry, not volume. Your eye properties will change in respect to your material properties. Okay, see this? If I change the material to gold, your mass and changes, but not your volume. If I change it back to, I don't know, ABS plastic, see that? Your mass changes. Mass properties is very interesting and very useful in physics. Or in the design, or you're trying to find other information. Your mass technically is the weight of the object, but only on planet Earth because of our gravitational pull. The minute you get off the planet, weight changes, but mass does not. Got it, guys? So if you were trying to get the weight of the object because you're trying to assess whether, how much is it going to weigh for shipping costs, of course you need to know the weight of the packaging. That's another conversation. But at least you know the weight of the product. Cool? Not that this is a physics class, but just be aware of that. You can get a lot of physical properties off this part, if assigned correctly. The material properties is what I'm referring to. That ends the video for modeling. So I'm going to stop this video. I'm going to